I want to talk about approaches to the treatment of mood disorders, depressive disorders in general, and our focus currently within the Brain and Mind Research Institute at the University of Sydney, with our partners in the Woolcock Institute and the Charles Perkins Centre, on focusing on 24-hour body clocks, their monitoring in people, and using that as the basis for developing new treatments and new ways of working out whether treatments actually work. Now, I have some important disclosures in this area. We work with a number of different agencies, not just in the health services environment supported by the NHMRC and the Australian Government, but also with industry in the pharmaceutical area, and particularly with some companies that are involved in the production of some medications that are relevant in this area, as well as a series of other private developers. And I should add that we're also part of a large cooperative research centre, the Young and Well CRC, led by the Inspire Foundation, which is in the process of developing technologies, particularly monitoring technologies related to this area. Now, for those of you who have any interest in mental health, you're probably aware of this concept of a DSM, a Diagnostic and Statistical Manual developed by the American Psychiatric Association, which has dominated thinking in psychiatry about what constitutes a disorder for the best part of the last 30 years. Only trouble is, for the best part of 30 years, it hasn't really helped us solve the problem of actually what are the underlying pathophysiologies or underlying mechanisms of disease, nor has it really helped us fundamentally in planning treatments at the individual level. Now, that's got to do with a lot of technical issues in mental health, looking at the brain in real time, looking at function in real time. Also, the incredible variability of humans in their heads. If you think humans look different in real life, like physically, go look inside their heads. They're really different. And unlike other disease areas, whereas cancer might be thought of as a single cell disease fundamentally, or organ-based disease like heart failure, brain-related issues are multiple systems that are operating. When they operate in synchrony and they operate well, that's great, we can all function. When they start to fall apart or fall out of rhythm with each other or out of synchrony with each other, they create major variations. And the brain itself is changing continuously in relation to environmental and illness inputs. So there's an enormous genetic variability to start with in life, and then as life goes on, you get more and more different in your head. So actually a lot of group stuff in mental health is very hard to organise. So while depression is the biggest category we have in the mental health field, it's also, in fact, the most diverse. And there are fundamentally different trajectories of illness underpinning that, particularly by the age of onset of illness, what the causative factors might be, what stage of illness you're at, and what treatments may arise. From a patient point of view, or someone experiencing one of these disorders, some of the really big issues that bother them are impacts on daytime function. They're not just low mood, they're really low energy, poor function, impacts on sleep, and the tendency for these disorders to recur. So although you may recover initially, the tendency for them to come back repeatedly, and their episodic type nature. And their episodic nature is not something that we fundamentally understand well as to why they come and go in certain circumstances. Is often a very unrealistic set of expectations in this area that will come up with one magic bullet for depression, whether that magic bullet's a psychological therapy like cognitive behavioural therapy, or a magic bullet like selective serotonin reuptake inhibitors, Prozac-like drugs pharmacologically. For a very diverse condition amongst very diverse people, that's a very unlikely outcome. So just like in the rest of medicine, a movement towards more personalised approaches, trying to match the treatment much more specifically to the individual, and then within that individual try and solve specific problems within the whole construct, is where much research is headed. Another really important concept here is when these disorders actually start. We typically treat people in our healthcare systems in Australia for depression in their mid-30s and 40s, but actually they've typically been unwell for about 20 years at that point. Most depressive disorders actually have their onset in the adolescent period, post-puberty, in association with most other major psychiatric disorders. So one of the issues we have when we often study populations when they're older is you not only have all the problems related to illness, you have all the problems related to chronicity and what might have changed in their brain, in their head, in their life as a consequence of being unwell for a long period of time, which is not really fundamental to the disorder, but it's a consequence of living with that disorder. So we focus a lot of our work on what actually happens during the critical age of onset, which is post-puberty between 12 and 25. There's a tendency to talk about adolescence as if it's just one thing. In fact, adolescence from a brain point of view is an incredibly complicated thing. This is just one set of studies from twin studies looking at how many different genetic components contribute to the outcome of being depressed at age 20. And just genetically, there's at least probably 4 critical transformations during that period. Much of that played out in different types and places and constructs of brain development as well as other physical development. That's not to mention the number of social transformations that actually go through that area. So the area of onset is actually a complex one itself. Some parts of that particularly late adolescence, are associated particularly with frontal lobe development and modulation of the one thing that I'm going to talk about in detail, sleep-wake cycles in the later adolescent period. Now, within the mood disorder category, we try to break away from the concept of major depression, which has been very important in a public sense. You know, in talking public health, you want to talk in simple terms about general concepts, and that's been very helpful, to what actually might be the trajectories. And there are three that we are really focused on. One where really temperamental or inbuilt anxiety drives you first in life to anxiety and on to depression. The one I'm really going to focus on, which is around body clocks or circadian systems, 24-hour systems. And the third one got to do with the way the brain develops itself or goes astray, developmental trajectories. There are three different concepts that we deal with. And what we try to do is track in the adolescent period what is happening in the development of the phenotypes or the clinical symptoms that we see in relation to what is happening in the brain, also what is happening in the body in terms of puberty, brain development, and particularly for some intrinsic systems of the brain, for this, in this case the sleep-wake cycle, what changes it is taking place. Looking backwards, there are often childhood antecedents of these particular areas, but these are the three trajectories we are most interested in. And the one I want to dwell on today, which is about 30% or so of the cases that we see in adolescence, has to do with what we think is the fundamental disruptive system, the circadian or 24-hour body clock, and the way it's associated with fatigue, which is actually more tiredness than moodiness, but also changes in levels of activity from areas of low activity to periods of high activity under certain circumstances, which we typically in the psychiatry world refer to as hypomania or mania. Now, the bottom of all this is that thing that we live on, the Earth, actually has a very fixed rotational system that has a very fixed 24-hour clock. Now, I don't mean to offend those who believe in intelligent design, but it is rather odd that humans don't actually have a 24-hour clock. So we have to reset our clock continuously, and the survival or the evolutionary issue is that those of us who are closest to 24 hours probably are most adapted. And those who are not very close to 24 hours have a great need to reset. Now, if you can reset, that's good, but genetically and developmentally you may have trouble resetting, and if you don't reset, you will tend to move out of synchrony with the natural cycle. And much study in jet lag in humans and animals over the last 20 years has really indicated the extent that if you are not in synchrony with the revolving Earth, there are many physical health and mental health consequences. This is very well summarised in a recent book out of the Munich group about internal time to make some really fundamental points about the clock. So what's actually happening in your body is not controlled by the rotation of the Earth. It's controlled by your own biological clock. And since your clock is not like the one on the wall here, or the one on the wall here, for those who can see, it's even out of time with itself this morning, you know, it's actually not 24 hours in length and therefore has to reset to match that external world. Otherwise, you will get very unwell. What is not so clear to people is the extent that that varies normally from individual to individual. Quick whip around the room here. Who are people who love the early morning? And who are those who love the evening? Good, that's two of us. It's widely distributed in the population. About half put themselves in the middle, and about a quarter are distinctly morning, and they're very moralistic, those morning people. They jump up, early bird catches the worm, they don't know what's wrong with everybody else, lazy people lying around. If you come back in the evening, they're the same people who are real party poopers. They want to go to bed, they're not much fun. In the evening, people come into their element. You know, what is wrong with those morning people? Why can't they join in? You know, it's quite widely distributed. It's very strongly genetic. It's not something you actually chose. It's very strongly built in. Sadly, from a mood disorder and mental health point of view, if you have a choice, be a morning person. Because it's more easily actually entrained with the clock, with the rotation of the Earth. Sadly, those evening people, we're remnants from some other evolutionary period, like rodents, who much prefer the evening. You know, there are different species have evolved in different ways for survival ways, but from a human point of view, we find a greater association between being an evening type and less stability of the clock and the sort of problems that we're associated with. Now, this clock stuff just ain't in your head. It doesn't just determine your behaviour. It very much determines the synchrony between a whole lot of other internal hormonal, metabolic, immune systems. So, for any of you who fly around the world moderately frequently like I do, you'll be well aware of the concept of jet lag and how awful it is when those clocks get out of synchrony with each other, and how much you can't really function some days up to a week to come back to the moon. And that every organ actually has its own clock. If you do that kind of stuff, you'll realise the sleep-wake cycle takes a long time to realign with your gut and several other functions over that period of time. In fact, your gut takes the longest to get itself back into time in association. Just imagine being like that, not for 3 or 4 days or a week. Just imagine being continuing to be like that. Might give you some insight into what it's like to feel depressed in this particular way, which is not so much to be preoccupied with your mood, but to be preoccupied with being very unwell for reasons that you cannot explain. And in association with that, to have bodily functions that are all over the place, and having profound tiredness and lack of energy and a lack of capacity to engage. So you sort of go about your business, but you sort of can't really get engaged with it. And fundamental to that is the loss of pleasure in association with doing what you normally do, a loss of enthusiasm, which as much as depressed mood is one of the central characteristics of being depressed, what we call anhedonia, or lack of hedonism, and lack of pleasure in life, so you just kind of exist. If any of you with jet lag sat through medical conferences on the other side of the world, you know what I mean? You sort of sit there, and you're there, but you're not really there, you couldn't care less. You wake up 3 days later and realise somebody said something really important, but you failed to impress you at the time, you weren't really engaged with it. And the other mood state that runs with that very much is one of irritability rather than depression. You know, rather short-tempered, rather difficult, rather easily frustrated. Because what you really rely on to be well is that rotation of the Earth, taking in the signal, particularly from light from the sky and humans, which is particularly important, through the human master clock, the suprachiasmatic nucleus, which regulates the internal brain system, through the pineal gland, through the release of melatonin, and that sets the daily clock. It also changes in relation to seasons. It also is profound in terms of the onset of the sleep cycle, or the setting of the daily sleep cycle, and to a range of other patterns, including eating, sleeping and exercising, which help to coordinate that. And then everything else that matters downstream at an organ level depends on signals from the master clock, hormonally, but also via body temperature and other nervous signalling, to coordinate it all. And in the ideal world, all these clocks are running in synchrony. So they're all doing the right thing, and behaviourally you're doing the right thing. You're up and active when you should be, you're eating when you should be, you're sleeping when you should be, in association with those internal rhythms. What the rest of us call health and well-being, good functioning. When they're out of synchrony, these are like clocks on those hotel walls you see, Tokyo, Singapore, whatever, but they're actually not running together, a bit like the clocks in this room. They've got their own mind and they're running on some other system which is actually poorly coordinated on those particular set of issues. And that's the fundamental phenomena of desynchrony, or of uncoupling of those clocks, which we are studying in relation to mood disorders. It also raises the issue of, well, how the hell would you get these things back in alignment for people whose clock has a natural tendency to wander under certain circumstances, like change in seasons or environmental stress or other behavioural sets of issues, or just for reasons we do not understand, it switches from one way of doing things to another, which is characteristic of the mood disorders. We can see some of the things that you would do have very much to do with light exposure and the timing of light exposure. Some things might have to do with use of melatonin and melatonin-related drug agonists. Others will have to do with daily patterning and what you actually introduce into patterns to try to control these sets of issues. So to be well in the circadian sense is a physiological set of phenomena that change across the daily cycle, but importantly, actually behaviour also changes across the daily cycle. So if you're choosing to have a major surgical operation, have it in the morning, okay? Surgeons are really good in the morning. They're alert, they're actually in a reasonable mood, they actually react reasonably well. Don't have it at 11 o'clock at night, okay? Bad time to choose. It turns out if you want to have chemotherapy, actually have it in the morning, okay? Because your immune system's basically like a surgeon. It likes to do things in the morning, it does completely different things in the evening, and there are good studies to demonstrate a whole lot of things that depend for optimal outcome on actually when you do these things, from a physiological point of view as well as from a behavioural point of view. It is normal to be tired and grumpy in the evening. It's better to be less tired and less grumpy in the morning. There's faculty meetings and whatever else. Have them in the morning. Don't have them late in the evening. Bad stuff can happen. What you want to have, therefore, is a system where at least these key elements are coordinated, and they're coordinated with what you do behaviourally. So the here issue is of entrainment with the normal 24-hour cycle, the rotating cycle. So things like your core body temperature falls during sleep, plasma melatonin comes on late in the evening to set the timing of this cycle, and things like cortisol fall later in the day, rise in the morning to help you be active. It's not just the shape of these curves that matter, it's the coordination of the systems. It's the system biology to be in sync, which is critical. So the type of what we think is happening in the circadian-based mood disorders, circadian-based depression, is that something's wrong fundamentally with the biological clock of people who are predisposed to this particular set of issues. About a third of people we see in young people. Now, so-called, in young people, called atypical depression, but if it's happening in a third of people, it's actually pretty typical rather than atypical. It's very common in that early onset phase, during the adolescent phase when people's sleep-wake cycle shifts anyway to be somewhat later. We now are making more and more use of novel assessment techniques, some in real time. Actigraphy is wearing watches and recording devices, very popular in the fitness industry at the moment, but also in the sleep-wake cycle, to record what you do, when you do it, and how much activity you're actually doing. Very useful for us in this area. Plus in the laboratory to actually measure melatonin and its movements across 24-hour days. we're focused on, okay, can we use this to target interventions then for people who appear to have this problem from a diagnostic point of view, but from an intervention and response to treatment point of view as well. So behaviourally, on what they do, sleep-wake cycle, not just whether they sleep. As I say to the sleep people all the day, I don't care what you do when you're asleep, I care what you do when you're awake. Like, do you get up, do you be active, do you expose yourself to light, do you exercise in a way that was likely to entrain your particular system? The pharmacological issues are those of this being melatonin responsive, and just to go back, actually serotonin, our favourite drug in the depression area, actually tends to disturb this particular clock, not to reinforce it. So a bit of a problem for us that one of our favourite antidepressants actually operates in a different kind of way. This also takes us back to things that we've known for a very long time, particularly lithium, which its therapeutic use was discovered in Australia over 60 years ago. It actually has one of its principal effects pharmacologically on the brain by actually affecting the circadian period and stabilising the clock. And we're involved in the testing of many other substances now for their effects on the clock. For those who are interested, we have a summary in The Lancet in August 2011 about the types of changes in clock that you can see in association with depressive disorders. Classically, in older people with depression, the extent to which they have phase advance, they go to bed earlier and wake up earlier, as distinct from younger people with depression who have phase delay, they go to bed later and later and sleep later and later. And then the extent to which when you're severely depressed, the whole thing starts to fall apart. So you end up with multiple sleep periods and no real good day-night differentiation and loss of coordination of the internal cycles. So if you go around and you mess with someone's circadian function, you deliberately do it, you can actually produce, in a sense, stereotypic phenomena. So this is typically what happened. Our best example in the modern world is jet lag. It's the thing that we do. There are others like rotating shifts where you can make people do this stuff, where you can just be really nasty. You can put them in labs and just mess with it, take away day-night stuff. What we know you do, if you do all that, is this is how most people end up. They wake up, they're still tired. They're tired all the time, they're awake. They can't think straight, they can't be alert, they don't concentrate, they can't remember. They get really irritable. Really nice people suddenly become really irritable on an ongoing basis. And they actually have loss of their normal regulation of body temperature, so they think they've got nighttime sweat, they think they're hot during term, and they develop musculoskeletal pain. So it's really interesting that you can produce phenomena by actually impacting on that system. The proof of principle in humans is important in that area. In the general mood disorder area, in addition to the depressive side, we're interested in the other side of the coin, which is about activity. So a lot of our construction around mood states is to stop talking about mood and talk about energy and activity, which is why recording activity with things like watches and stuff becomes so attractive. That there are high activity states and low activity states that we're interested in. And what's also interesting then is they exist, what drives the switch from one to another? How can you suddenly in one episode be like one thing and then suddenly it goes somewhere else? We know something about switches. We know about the extent to which changes in the light period with season will drive switches. We know some things about medications that will drive switches, and we know certain things about things like travel, shift work, and sleep deprivation. We know some other things like developing infections, for example, that will also drive these sort of phenomena. So our work is based on trying to understand what is happening with the brain clock, what's the genetic vulnerability that we inherit, how that plays out at different ages within different environmental exposures. So in children, you're likely to see difficulty with sleep patterns and feeding patterns. In primary school, attentional issues and chaotic activity patterns, having trouble settling into regular patterns. The area we're most interested in early adolescence, developing a depressive type that's not just irritable and tired, but also tends to gain weight rather easily, develop metabolic complications. And then in later adolescence, the extent to which it tends to develop switches into high activity states as well and low activity states. And we study this in a whole range of populations, in the population here in Australia, in Brisbane Longitudinal study in the United States, in big population studies, with our CRC in Australia, we're tracking with technology, in family studies, in clinical cohorts, and in animal models. So we're exploring these concepts in a whole range of different settings. Just for time's sake to say, there are a number of key publications here. This is one exploring fatigue states in adolescents in association with mood disorder in the United States. Oops. Others in relation to the inheritance of this thing, and it's really the atypical group, which is highly heritable, so there are strong genetics. We do this also in partnership with the Brisbane Longitudinal study of adolescent twins, so following twins over these particular periods. And we do it here in Australia and in the United States in various models. Here in Sydney, we like people and we like zebrafish. In our other partners in the United States, they like migratory birds and primates, where we can study these sets of activities across species. So rather than mood states and cognitive states, studying activity cycles across species is rather easy. So we are involved here in Australia with recruiting young people through our headspace types into these types of studies. We're interested in improving outcomes, not just in their depression, but across a whole range of other areas. And I'd really just to highlight here, enhancing their physical health by focusing on these cycles. And we conduct most of our studies in these areas in people who have not yet developed fully complete depressive disorders. And that's quite, and the brain correlates of that, that's quite different to where most traditional psychiatric research goes on in midlife. So we're into the business, to quote a very famous scientist, Joe Takahashi from the United States, into what makes a good clock and what makes a good clock therapy. So just the bottom line of all our research, and I'll stop here shortly, is a good clock is one that's easily entrained, but also is rapidly restored after disturbance. If you think about biological systems, they should work normally every day, but if something comes along and pushes them, they should restore themselves rather easily. If they're too rigid and they're pushed by environmental events, then they'll cascade totally out of control. So the idea of what's a robust clock is something that normally entrains itself well and responds well to actual change. What we find in all of our studies with young people with these sorts of disorders is they lack these two characteristics. They're not well entrained, so our people with severe depressive disorders run different clocks, and they also are highly variable. They're highly easily disturbed. On what makes a good treatment, from a behavioural point of view, it's getting the light exposure, the exercise, the activity, the feeding patterns in regular patterns that respond to where the clock is in its normal cycle, which is bad news for a lot of young people. It's getting out of bed in the morning and being active and it's doing light exposure. For the rest of us, there's a whole lot of bad stuff. You'd eat in the middle of the day, not in the evening. And it actually is, you would go to the bed in the evening. You would not be a rodent and stay up all night. You would actually do other sets of issues. Increasingly, there's a whole range of pharmacological options, lithium, melatonin-based antidepressants and other new agents that are working on these particular things as we understand more of these particular elements. And these are issues you can look at in our publications in these areas about circadian profiles in young people. And I particularly recommend from a treatment point of view an article in BMC Medicine we have recently about manipulating the sleep-wake cycle and circadian rhythms to improve the clinical management of major depression, which summarises these key issues. Oops. So the bottom line of all of that is for this kind of depression, we are trying to develop the specific behavioural interventions that would make a difference. We're trying to investigate, and they're first line, that's what you would do first. Second line, what sorts of pharmacotherapies would make a difference. And then there are a whole series of experimental sets of operations in place as to what new treatments might be available to make a difference. But along the way, really importantly, to start to use other assessments continuously, like actigraphy in real time, and other things like melatonin assays in real time, to see the extent to which have we put it right? And is putting it right associated with resolution of the problem in the first place? Marvellous to have these grand theories about what really works, take them out of the clinical trials into individuals, and do they really work? So our area is one in which we have to take the general principle rapidly back into N=1 experiments and say, does it really work for you? And are there circumstances in which that would be optimised? So that's a really important set of technical assessments in our area of mental health, of tying technology to the assessment and to the responsive treatment. Providing patients with lots of good information about this kind of stuff, lots of good information about their clock and what happens across that particular period, what they need to do at critical times of day. There are other issues about light administration that come into play. As I said, a whole range of new pharmacological options as to what is taking place and where we go. So in summary, we're really interested in these particular types of depression that are linked to body clock disturbance, really obviously associated with low activity, phase delay, metabolic complications, particularly relevant early in the course of illness. We're trying to sort out at this stage what is the optimal combination of pharmacological behavioural interventions, but just as importantly, what is the optimal way technically of working out in the individual what is wrong with their clock, and then making sure we reset that clock. And if we do reset that clock, do they get well again? Thanks.